1 terabyte on EFS, $307. On S3 files, just $25. POSIX mount, the same read file calls, and Lambda handles it like a normal file system. There's a catch too actually, and I will tell you before you migrate everything. EFS has 3 billing layers, and most people just are aware of one. The first one is storage. It's 30 cents per gigabyte. That's the number everybody knows. Then there's throughput. Bursting sounds free until you hit the credit limits regularly. Then you're looking at provisioned throughput, which comes at $6.60 per megabit and month. This is on top of the storage. A team provisioning 100 megabits per second is paying $660 per month before storing the first byte. Then there are also charges for infrequent access. It's 1.6 cents per month and gigabyte, but also 1 cent for every gigabyte that was read. This means a 100 gigabyte dataset that gets pulled once will cost $1 just in retrieval costs. None of these costs are hidden, but calculating your costs upfront is really difficult. S3 Files is a managed NFS file system that's backed by an S3 bucket. 3 resources need to be understood. The file system maps NFS paths to S3 object keys. It's the top level construct. The mount target is the NFS endpoint in your VPC. Lambda connects to it via port 2049, so the same port as EFS. The access point is a scoped entry with a POSIX user and a root path. Lambda uses the access point ARN to mount. One really surprising thing is that the IAM role you're using need to use the elastic file system.amazonaws.com principle. That's the EFS service principle, so not a new one. S3 Files shares the NFS layer with EFS. Only the storage backend differs. Your Lambda function uses file system configs exactly like EFS. So mount path and access point ARN. You can use standard fs.readfile, for example, inside your Lambda function. Nothing in your application code needs to change. Here's where S3 Files gets more interesting than the headline number expects. Large files, so 1 megabyte and above, will directly stream from S3 when read. No cache involved. You pay the default 2.3 cents per gigabyte a month for storage, and there will be no additional charges for S3 files. That's where the 13x comes from. Small files are different. Files that are below 1 megabyte will go in the high performance cache, which is charged additional. You will be charged 30 cents per gigabyte and month, in addition to the 2.3 cents that you're already paying for the S3 storage. For 1 terabyte of small files, that's an additional $330 a month. EFS standard is just $307. This means S3 Files is already more expensive than EFS. S3 Files costs are really hard to predict upfront. EFS is mostly simple. You can just multiply the 30 cents for your gigabyte that needs to be stored, and it will roughly get your costs. S3 Files really depend on your access patterns and the cache hit rate. A workload that looks cheap on staging could probably end up really expensive on production if file sizes change. Before committing, really check the numbers and file sizes and your access pattern on production with your expected workload, and then just calculate the numbers. When Lambda writes a file, the file ends up in the kernel's NFS cache first. The NFS client then flushes the file to the mount target. The mount target then pushes to S3, 2 hops, which can take up to 60 seconds in total. Invocation A processes a job and writes file a.json. Invocation B triggers seconds later, also tries to read the file, but gets nothing. That's because the write hasn't flushed yet. This breaks any pattern where files are used as a coordination signal between different Lambda invocations. Job queues, status flags, log file, handoffs. On EFS, these work fine. On S3 Files, they will just silently fail. As a safe mental model, treat S3 files as S3, but before introducing strong consistency. Always assume a different Lambda function invocation won't see your file for up to 60 seconds. If you need coordination, please use DynamoDB or SQS. A few failures aren't obvious. So for example, hard links aren't supported at all. This means if you're using rsync hard links, it will either error out or will just silently copy. Advisory file logs, so for example flog, will work locally but will have no effect on concurrent executions. Regarding Python's file log, npm's proper log file, or Webpack's build cache, two concurrent executions that are writing can silently corrupt without throwing any error. Also, directory rename isn't atomic on NFS. Many tools like Git or npm use a strategy called write temp and then rename for a safe write pattern. On S3 files, this partial state on mid-write is visible. SQLite and other database systems have another problem. They're using log files for write serialization. This is not working on S3 files at all. Concurrent access will corrupt data. You need to use DynamoDB. On the positive side, if your code is just using read file, read directory, you will be fine. The whole setup is just a few SAM resources or whatever infrastructure as code tool you want to use. First thing, Lambda needs to be inside a VPC to reach our mount target over NFS. This means we need an S3 gateway endpoint. Without it, NFS traffic would route through the internet. Then we need security groups. Lambda egress on port 2049 and mount target ingress from Lambda on port 2049. As mentioned earlier, the IAM role that we're using needs to trust the elastic file system.amazonaws.com service principal, not the S3 principal. It also needs a BART multipart upload for uploading large files and event bridge access for internal AWS housekeeping. The file system creation also needs to have accept bucket warnings true. This is necessary because once the file system is attached to a bucket, S3 files will take over coordination of the bucket. You can no longer freely mix S3 file access for that bucket and directly using commands like put object onto the same S3 bucket. Objects in S3 appear immediately inside the file system, so you don't need any SDK access anymore. Normal FS operations are enough. We've created a sample repository which sets up a full SAM stack in your AWS account. You can find a link in the description. So now to the last part. When to use what? Use S3 files when your workload rather consists of large files, so above 1 megabyte, and your workload is rather read heavy or write once. Also, obviously, if you need access to data that is already in S3 and you need POSIX access. EFS still has its dedicated use case. Use it when you need immediately read after write consistency between different processes. As a summary, the 13x cost gap is real, but just for large files. Small file workloads can quickly flip that math. Run your actual workload, check the cost explorer, and then decide. Our S3 infographics covers storage classes and pricing tiers. The link to it is in the description. It's free. If this is AWS knowledge that actually helps in production, subscribe. New video every week. This is AWS for the real world.